Hello, my name is Łukasz Langa, and I'm going to speak about Redis today. You can find me in all sorts of places over the internet. Let's start with the bird's eye view of Redis. Basically, it's just a key value store. It's a key value container, but with a twist. The keys accept any binary data, whereas the values are some sort of data structures. The most basic one is the string, but in fact it accepts any binary data whatsoever. But we have also hashes, lists, sets, and sorted sets. Apart from keys and values, the Redis server, but this is only a means of, to be easy to use, it has this notion of databases, which are really just namespaces. So when you select a namespace, which are just integer numbers starting with 0, you get a different namespace. And apart from these blocks, we have commands. So this is the way you actually access the data and mutate it in a Redis server. You can set it, get it, delete it. Okay, I'd say you can go quite far with just those 4 commands, but it wouldn't be much fun, wouldn't it? Basically, the most controversial thing is that the dataset is in memory, which means that if you don't think about data persistence, your data won't land on a disk, and after restarting your server, you'll lose it. So for that not to happen, Redis provides 2 approaches. The first one is RDB, which is basically save the whole dataset to disk with some sort of rules applied to it. And the other way is save the command log to disk. So you don't have the data on disk, but the sequence of commands that the clients issued. They are in sequential order because Redis is transactional by default, and each command is atomic. So every mutation of data is basically sequential. So the data persistence is configured in 2 ways. RDB is configured so it saves the keys each and every save of a single key, 10 keys, or whatever you specify. And this is the time after which those saves should be done. The append-only file is easier. It just states how often should it run fsync, because one of the less fortunate decisions of Unix and POSIX later is that the sync command basically syncs everything on your file system. You cannot specify that only sync this part of the file system. So you have 3 options of append fsync. So don't do it, let the operating system do it. Do it every second, which is the most, the best maybe compromise between persistence and performance. And you can fsync always if your data is really important and you cannot afford losing even a single command, because this is the append-only file. So basically, RDB has better performance, whereas the append-only files have better crash tolerance. Redis also supports replication. It supports replication in a master-slave tree, so slaves can have other slaves. But basically, the replication is non-blocking, which means that the master keeps serving data even though it knows that the slaves are not synchronized yet. And moreover, a slave will serve data even though it knows it has outdated versions. This second thing can be configured to fail, but by default it serves stale data. So what is it for? Basically scalability, right? You can configure your client to do the read operations from the slaves so it doesn't hit the master, and only save to the master, because the master-slave replication really means that you cannot replicate back replicator saves. You can then turn off RDB and the append-only file on the master and only save the data on our slave with a faster hard drive. And specifically, this is done to make the slave an environment where you know that the fsync will only be done by the Redis server. So basically, a very small instance, a very small server, which does not do anything else. You can also offload heavy operations to slaves. We'll do some discussions of that later. But this is all boring, and it reminds me of my university lectures and stuff, so let's use it. To use it, you have to first install it. But the latest Debian stable and even Ubuntu LTS do have a very old version, which makes me unhappy because you really want the new one. You really want it because it has all sorts of cool things in it. Basically, it uses less memory and fragments is less. It supports variadic comments, so increases atomicity. And it's easier to monitor, it's more performant. I mean, there's not real... there's no use in using Redis 2.2 or even older. You should really go and fetch the latest version. When you run the server, you just get this ASCII art. In one of the logs, when Redis 2.6 was happening, the author entries said that, yeah, most of our workload went to make this ASCII artwork. So, yeah. You can connect to the server in a variety of ways. First of those is Telnet. So this is one of the biggest, I'd say, advantages of Redis, that it's totally transparent. You can basically do everything you need to do with Telnet only. So there is no reason why any programming language or any environment couldn't use Redis. You could use it with most anything. So we select a database, set some values, get it, increase those values, stuff like that. You can do the same using a dedicated tool which Redis provides, which is simply called REDIS-CLI. So REDIS-CLI, the thing it does give you is it formats the values in a way that it's better understood by humans, whereas the last one actually provided some sort of simple protocol, which meant that, yeah, now we are going to receive our list or something like that. So here's what REDIS-CLI is for. But then you can also access it using a programming interface. Let's use Python. As you can see, it's basically the same thing. And even if you don't use Python, it's really transparent. Everything that happens here happens just in the same way. If you do use Python, just install this library. There are a couple of others. You want this one. But what commands can we really use on the server? Basically, Redis has a really good documentation with a single page that describes all of them, all of the commands that you have. You can filter it so that only the things that interest you, for instance, lists or pub/sub, are listed. And this documentation is fabulous, not only because it describes how the thing works, but also because it describes stuff like, let's say, bit count, computational complexity. So you know how fast a single operation will be, or how slow, depending on your workload. The other thing is that it has examples. So down there are examples, and these are interactive. So you can actually type new Redis commands just on the side and see whether this works or not. So this is fabulous, and this makes working and learning to use Redis even easier. So highly recommended. Let's start with talking about the data structures we have. Let's start with string. String is unfortunately named because it's any binary data. Any binary data up to 512 megabytes and supports stuff like incrementing and decrementing. Most people would disagree that strings should be incremented or decremented, but basically strings are all there is in terms of the basic data structures. So if you happen to put a number there, you can increment it or decrement it and do all sorts of bit operations on it. So you can pretty much do very compressed flags on your application. Let's use it. You can set anything, increment it, and this is important. This is output from REDIS-CLI. Does not mean that you do have a data structure of integer. This is only a protocol thing. So the Redis text protocol gives you a number back. But it still means that when you get the number, you get the value of a key, this is a string. So you can check how long it is. Yeah, it's 3 characters long. How many bits are set and stuff like that. Basically, really simple. This is something that I will be possibly telling you on and on, that Redis is simple, because this is the single most important thing that I want to tell you, that don't be afraid, because this is something that can actually be understood on, in its entirety. You can do things like setting a value only if it wasn't set before. You can set multiple values in one operation. And you can expire keys. So you can say that this key is only valid for a number of seconds or even milliseconds. So you have the variant with millisecond precisions as well. But those commands were used so often that Redis also provides a variant of the set command that enables you to set the expire in one operation. So basically, you have the time command that gives you back the time of the server, the time that it is on the server. If you set a key, you can also expire not by seconds, I mean by a number of seconds, but by a timestamp, which is also useful in some use cases. And the nice thing is that you can actually check the time to live for any key. So you can say how long will this key be still valid. These commands, I mean setx, psetx, and multiple set were only useful because Redis originally didn't support transactions, but it does now. It supports transactions, but these are very unlike transactions from relational databases. Basically, it all comes out to 2 commands, multi and exec. Everything that happens between multi and exec is queued, which Redis tells you, until you run exec, and then it's run sequentially so that you get the outputs of your commands in a list. The important thing is that this is all run atomically, so no other concurrent session will put a command in between your transaction. Redis will sort them in a way that it'll run the transaction on its own. Even the append-only file makes sure that the multi-exec things are stored together. Sometimes even compressing the commands in a way that they're shorter, so using mset, setx, and stuff like that. But what if a command fails? If a command fails, then Redis does something which is very unnatural for people used to relational databases. Basically, there's no rollback. Redis simply says that, okay, from the 3 commands I ran, one of those errored out. Sorry, you have to deal with that on your own. People ask, why? Because this is the only easy way to do it, and most applications are totally fine with it. Nobody will do banking systems based only on Redis, so this is a total non-issue. But you can sort of live with it using the fact that there's something like watch. Watch lets you fail the whole transaction if a certain key changed in between, which means if you said, Polish client, woo, if you set Redis to watch a key and then set up a transaction and run it, it will not run at all if there was a change on the same key from another session in between. This solves many of the problems we usually have with transactions as we know it. So, strings, transactions, let's go for the more interesting data structures. Let's start with lists. You can manipulate lists with pushing values to one end or the other. Both operations are O1, very cheap. You can even insert values in between, but this operation is already ON, which means, sort of, you have to consider the length of your list. But basically, the REDIS-CLI indexing is inconsistent. And this is something of a pain of mine, that you do list from 0 and get values from 1. Okay, this is only a tool, but still kind of ugly, isn't it? And if you program it in Python, you're used to slicing, where -1 means not the last element, but the element before it. So this is also inconsistent with that. But if you actually get used to it, it works pretty nice. You can also trim lists, so you could cut values that you're not interested in, and you can pop values from both sides as well. Pops are O1 from both sides as well. Hash tables. With hash tables, you can actually put more interesting data into a single key. You do that by setting a value in a hash. One thing I didn't mention before, it applies here too, is how do you know that there's a hash but it doesn't have any keys in it? And how do you know there's a list but it's empty? Basically in Redis, you do that by unsetting the key. If there's no key, it's an empty list as well. So Redis doesn't differentiate between an existing key and an empty list. An empty list doesn't make sense for Redis. Once you put the first value on a list and the first key on a hash, it starts being existent. It instantiates. You can set multiple values. You can check all keys. You can delete values. This is all very natural for any language whatsoever you previously used. So this is only one slide because, basically, what else can you do? PubSub. PubSub is very interesting because it lets you subscribe to stuff other clients publish. And the stuff they publish are simple messages, simple text messages. Like keys and values, they can be any binary data, but usually they're simple text. So you can subscribe and then receive a message from Redis on a specified channel, because you subscribe to channels. If you then unsubscribe, you stop getting messages from it. That's it. There's also server-side scripts. Server-side scripts let you evaluate stuff that Redis doesn't support, on its own. So there's an eval command, which basically means you run Lua 5 code with some libraries already included for you. What's important is that you don't have any other libraries available. So these are the only ones. This is another case where the authors of Redis decided that it's better to be easy and simple than go and support everything and then there's a mess you have to support. So these are the libraries you can use. In the eval command, you also specify how many keys are there afterwards, and then you specify them. Note the one-based indexing here. eval, basically here, even if you didn't ever program in Lua, I suppose you know what this command does. It simply uppercases a key you specify. So if you specify another key, you can run the same command on and on. This is not very good for specifying very long scripts, because you keep specifying the code in your command. One thing is that Redis already caches the bytecode of the command, so it doesn't really compute, the bytecode every time, but still the bandwidth is pretty much wasted if the scripts are long. So this is why a script load command exists, which returns an SHA-1 hash, and you can then use eval SHA to specify the SHA. Here are 3 dots, but basically you have to put the whole key in, and it works. If we wouldn't have any key of that, any script of that key, we would get an error. But there are caveats of using Lua in Redis. Scripting engine has a contract that the script runs atomically. Just like any other Redis command, the author says that the script is guaranteed to be run atomically, which is why the scripts cannot access the outside world, so no HTTP communication, no files, no inter-process communication whatsoever. They even cannot create variables and functions, so they are really simple. Yeah, they cannot run other scripts as well, so you can run any other Redis command by redis.call, but you cannot run eval from eval, so yeah, too bad. The maximum execution time of a single Lua script is 5 seconds at a time. You can change it globally per server. This is really, it seems for a human that it isn't very long, but for typical Lua scripts which run under 1 millisecond, this is eternity. Scripts running too long are not terminated by Redis. You only get a comment that the server is busy, you have to kill a script on your own. And there's another caveat that if you try to kill a script that already mutated the keys of Redis, so the data store is in an inconsistent state, you cannot kill that script safely. You have to kill the server whatsoever. This is unfortunate, but this is the easiest thing that you can come up with. And with experience, I'm increasingly in favor of stuff like that. If something terrible happens, just crash it. Just don't try to recover using, a complex algorithm which you will have to hire a PhD to prove that it's correct enough for you. Just crash the thing and make your application support the state of a server crashing. So let's Redis some things now. Yeah, I had to actually use that image, but we already had it, so let's head to use cases. To do an equivalent of memcached, but better because you can run a command like keys, so you know which keys are actually on the server, just use setx, so all the keys expire, turn the persistence off, you don't need it in memcached, and shard in your application, like most memcached clients do as well, because memcached doesn't really do anything on its own in that regard. There's a Twitter project called Twem proxy, right? And this proxy was originally written for memcached, but when Twitter started migrating towards Redis, they started supporting this protocol as well. So if you want to shard, if you want to do application level replication, you can do that with Twem proxy. That's memcached. To do a log server, you simply use the setnx command, which returns 1 if the command succeeded and 0 if it didn't. So this is all you need to do to have a mutex. This is basically proved to be correct as a test and set theory. You can extend it by expiring the keys too, so that if you do get a lock and your process dies, after some time, someone else will get the lock back. This is basically what Zookeeper does, which is why it's so awesome. It also implements some more complex algorithms than that, but for your simple applications where Redis is already used for a queue or just caching values, this is more than enough usually. So message queue, right? Simply do a list of IDs and store the task metadata in a hash tables in keys named like the IDs. That's all you need to do, but to ensure you don't have to poll on and on, just use pubsub. This is not an idea I made up. It's actually implemented by Rescue and all sorts of other queue implementations that use Redis. But the one I want to talk about briefly is RQ. RQ is Python specific, but the concepts are really the same as in Rescue for Ruby. So to use it, you simply take any function. This is a typical Python function. It doesn't have anything magical at all. You can actually use it like a regular function because it is one. But if you do run on RQWORKER, then you can also access the queue and enqueue calls of that function so that they happen on the other side where the RQWORKER is running. Yeah, so what do you get when you enqueue a call? Naturally, a job object which has the status that it started, okay, it's running. And after our delay, you will have the finished status and return value, which Redis keeps for 500 seconds. If you're not interested in the value, it will not clog the server up. It will clean up on its own after 500 seconds. And RQ is really smart about stuff like that. For instance, if it loses the connection to Redis, it dies. Another instance of the thing I like about maintainable services, it doesn't try to reconnect, to re-establish the connection, doesn't try to do anything stupid like that, which you have to prove is correct. It simply dies. And you have to use a tool like Upstart, Supervisor, whatever, to manage that for you. This is the simplest case. But RQ is probably not interesting for you in terms of using it from Python, but it is interesting in terms of its implementation under the hood. So if you access the database in Redis, you see that there are a couple of keys. There are jobs, there are workers, and queues. So let's start with the queues. As I said, the queues are simply lists. So they keep IDs of the tasks, nothing else. So if you want to see a metadata of a single task, you get it like a typical hash. To get all the keys set in a hash, you simply run the command and you get back all sorts of information like the timeout specified for the task and stuff like that. The interesting thing about it is that the data to be run, so the functions to be run, in RQ it's using Pickle, which is Python object serialization. You could use JSON, message pack, whatever. For JSON and message pack, as you remember, the Lua scripting side of Redis supports these libraries, so it's useful even in that regard. But basically, this is a queued task, and it has a human-readable description, so the logs and everything actually specify what has been run with what arguments, which is really nice compared to RabbitMQ. And the hash of a complete task only differs because it has the finished status and hopefully a result. Not all tasks have results, this one does. It's an integer of 65,000. Okay, the failed tasks, on the other hand, have the failed status and give you the whole traceback what went wrong, which is really nice as well because you have all information needed to debug the thing. But why can I actually access the task like this? It's because Redis also keeps these results for 500 seconds, and moreover, it has this special failed queue. So if your worker supports it, if you want to support it, you can fetch tasks of the failed queue to, for instance, rerun them, or to some sort of monitor them and tell the developers that something went wrong. From the worker metadata, as you said that, as you saw, there were also worker hashes in the database. You can get stuff like birth, when did it happen, and which queues are supported by this worker, and in which state is it. Busy means it handles actual tasks as we speak. What's nice about it is that this is an expiring key. Here you can see it has some short time to live, which means if your worker will die, this metadata will die with it. So Redis is all you need to have to monitor whether your worker subsystem, whether your working environment works correctly. If you don't have workers, it means some of them died. Basically, I'm done with the talk. Redis is really simple, and I'm open to questions now. But the one last thing I want to say is that the number of times the word NoSQL appeared in this talk is 0. Yeah, well, now it's not. Now it's 1. But I hate the buzzword, but Redis is still very useful for all sorts of use cases you can imagine. You can reach me anywhere on the internet, and the slides are already available. You can download them if you wish. But I don't think it's actually that helpful, because as you saw, the Redis website has an interactive example section which you can use to actually teach yourself Redis in one day, I say. Thank you. Any questions?
Can it be in Polish? Okay,
Yeah,
it will be much simpler.
Yep.
Mówiłeś, że fsync flaszuje cały file system. Jestem niemal przekonany, że flaszuje tylko dokładnie ten plik. Zresztą tak naprawdę podajesz mu file descriptor, który ma sflaszować. Sync flaszuje cały system, no ale tego oczywiście się nie używa, no bo to, tak jak mówiłeś, jest to strzał w stopę lub też bezpośrednio w czoło.
Zgadza się, ale przynajmniej na Excie, tak czy owak, to jest blokująca operacja. Także jak zrobisz 2 fsynki jednocześnie, to i tak się serializuje. I jeżeli pierwszy fsync będzie trwał 2 sekundy, to ten drugi niestety wcale się nie stanie w tym samym czasie. Będziesz czekał tak samo długo. Więc no, pod tym względem to, jeżeli będziesz fsynkował zbyt często, będziesz blokował inne procesy na tym samym serwerze.
Okej, dzięki.
Okej. No jeżeli nie ma innych pytań, to dziękuję bardzo. Thank you very much.